Let's now turn to this hypothesis testing question where the null value is something other than 0. The average amount was 19.45 with a standard deviation of 6.23 when the waitress introduces herself by name. For 50 other customers, the average is 13.34 with a standard deviation of 5.1. Does the data suggest an increase of tips by more than 5? Use a 0.01 level of significance. Before we get started, we notice that we're looking for an increase of more than 5, and also that the average tip amount is 19.45, so that's a slight change perhaps from what you have in the write-up in your notes. So let's start classifying this. This is a hypothesis testing problem, and this involves an average. This is not a rate, even though the word percentage is used in the problem. The question is the average amount of the tip. This is a two-sample problem, looking at comparing the amount of the tip before when making introduction and when not making an introduction. It is a one-sided hypothesis question because the question is more than 5 percentage points. This one's unpaired. It's not a before and after. We're looking at, it's the same waitress, but it's 50 customers and then 50 other customers. And finally, because this is a large sample, each sample is size more than 40. And so therefore we'll use the test statistic Z. The null hypothesis will be that the difference in the means is 5 points. And the alternative hypothesis will be that the difference in the means is more than 5 points. Okay, so we now compute the test statistic. To get the test statistic, we figure out the standard error. And for the difference of two averages, the standard error will have the form first standard deviation, 6.23 squared, divided by the first sample size of 50, plus 5.10 squared, divided by 50. And that works out to be 1.1386211. Next, we figure out the Z value. In this case, the Z value we have, we want a 0.01 level significance, so we have the area to the right here is 0.01. And so the critical value is 2.3263. Using either the inv norm function on a TI calculator or else the norm sin function on Excel. Okay, so now we are in position to compute the Z statistic, the test statistic Z. That'll be the observed difference of 19.45 minus 13.34. So that's the observed difference, minus the expected difference under the null hypothesis, which is 5, divided by the standard error for the difference, which is the 1.1386 figure. And this works out to be 0.97486. So 0.97486 falls about here, and so our decision will be to retain the null hypothesis. Alternatively, we can figure out the probability of seeing something that extreme or more extreme. So finding the area, in this case to the right, of 0.97486. And I only figure out the area to the right because the alternative hypothesis has a greater than. So the p-value is equal to, if we work that out, to be 0.1648. So 0.1648, that is bigger than my value of alpha of 1%. And so the decision will be to retain the null hypothesis. So let's type out the conclusion. We retain the null hypothesis, or we fail to reject the null hypothesis. The data does not suggest that the tips increased by more than 5 percentage points. And so that is the way to do this problem. It's very much the same as before, except we have a null value of 5 this time instead of 0, which has been what we've seen mostly in the past when we've had differences.